Hey guys! So now that you've learned how to add, subtract, multiply, and divide polynomials, we're going to be factoring them and solving them this week. And we're going to start with factoring today. So factoring polynomials is very similar to factoring quadratics, and in fact we're going to use a lot of the strategies that we use to solve quadratics and apply it to polynomials. Remember, quadratics is just one type of polynomial with x raised to the second power. So in this unit, when we're factoring polynomials, we're going to focus on mostly cubic polynomials, x to the third power. So whenever we're factoring, we had said that our first step is always to factor out a GCF if there is a common factor, a greatest common factor that we can factor out from every single term. So if we look at the example, x cubed minus 7x squared plus 10x, is there a GCF that I can factor out from every term? And you might observe that, every term has at least one x. So x is our GCF that we're going to divide out from every term. And if I divide out an x from every term, I'm left with x squared in the first term minus 7x plus just 10. Okay, so once we factor out the GCF, if we end up with a quadratic, this is our quadratic, we're going to try to break this quadratic up and factor that further. And we remember how to factor it, right? So I'm going to do that over here. The x that I already factored out in the front, we're just going to leave that as is because I already factored that out. And now I'm going to work at trying to factor out this quadratic. And remember, our rule is we want to find factors of a times c using the x factor method and the sum of b. So in this case, a is 1, right? 1x squared, the coefficient is 1. And a quadratic is always in the form ax squared plus bx plus c. So in this case, we've got a times c as 1 times 10, which is 10. And b is negative 7. So I want to find two numbers that can multiply to give me 10 and add to give me negative 7. And so you might say, well, what about 5 and 2? That would multiply give me 10. If I wanted to add to give me negative 7, then how about negative 5 and negative 2, right? And with these two numbers, this is how we're going to break up this negative 7x over here. So in our next step, we're going to keep the x that we already factored out there, and we're going to break up the negative 7x into negative 5x and negative 2x. I'm going to split it up. And then, do you remember what we do after we split it up? We're going to group them. Right? We group the first two terms together and we group the second two terms together, and then we try to factor out the GCF from each group. So again, this x, don't lose it, it just stays out in the front. And then from my first group, my GCF that I'm going to factor out is x, and I'm left with x minus 5. From my second group, I'll do it in orange. From my second group, I'm going to factor out a negative 2 because the leading coefficient is negative, and then I'm also going to be left with x minus 5. And then we're going to regroup. From our two groups, we see that we have x minus 5 in common. So this x, I'm going to leave it out, and I'm going to factor out the x minus 5 that we have in common, and we're left with x minus 2. So there are three factors in your final answer. My three factors are x minus 5, and x minus 2. So once you factor out a GCF, if it's a quadratic, you just factor it like a quadratic. And remember, I showed you two ways of factoring quadratic. This is the ACB method with the x factor chart. You could also do the guess and check method if you want. Remember, the guess and check method is just you want to split up x squared into x and x, and then you want to find two factors so that that would multiply to give you your c value, which in this case is 10, so that when you multiply the inner terms, this gives me negative 5x, and when I multiply the outer terms, it gives me negative 2x. And it needs to add to give you your middle term, which is negative 7x. So that's a good way to check to see if you factor the quadratic correctly. Okay, let's try one example. One more example, and I want you to try this on your own. Factor out the GCF, so if you want to pause the video for just 1 minute and give it a try, and then go back and come back and check to see if you got it right. And then if you didn't, you can watch my explanation. Right, so GCF looks like all three terms I can divide out a 2, and I can also divide out an x. So I'm going to take out the GCF of 2x, and I'm left with x squared. Negative 8 divided by 2 is negative 4x, because I took one out. And then negative 24 divided by 2 is negative 12, and that x came out. Right, so then from there, I've got 2x, and I want to take this and factor it into, because it's a quadratic, factor it into two smaller factors. So in this case, I'm going to use my guess and check. For those of you who do like guess and check, I'm going to split x squared up into x and x, and then I'm going to split negative 12 up, and my options are 1 and 12, 2 and 6, 3 and 4. Right, I know I want to add to give me negative 4 in the middle, so probably 6 and 2, so I'm going to put negative 6 and negative 2 here, and then we're going to do a quick check when I multiply inner term, negative 6 and positive 2. When I do a quick check, I have negative 6x. When I multiply the inner terms, the outer terms, I have positive 2x. And then that adds to give me negative 4x, which is the middle term that I want. So that's it. Okay, these are my three factors. After I factor out the GCF, I just factor my quadratic using guess and check. And if you don't like guess and check, then we do the x factor, right? We want factors of a times c, which is negative 12, and the sum of b, which is negative 4. So multiply to give me negative 12, and add to give me negative 4. That's going to give me, my numbers are going to be negative 6 and positive 2, and then I break it up. So I'm going to have 2x out in the front, and I'm going to have x squared minus 6x plus 2x, split up the middle term, minus 12, and then we group. Factor out the GCF from each group. X, I'm left with x minus 6, and I'm going to make this bracket bigger so we don't get confused with all the parentheses. X minus 6, and then from the second group, GCF is 2, and then again I have x minus 6. And then from both of these groups, I have x minus 2 in common. So we have x minus 6 in common. And then we have x plus 2, and then we get the same exact answer. All right, so factoring three terms. If it's a polynomial, factoring three terms is very easy. You follow the same process that you would whenever you're factoring. Take out the GCF. If you're left with a quadratic, see if you can factor that further. Sometimes you can, sometimes you can't. Most likely you can. Okay, and then today we're going to look at one other example. What if we have 4 terms? We have a polynomial with 4 terms. It's actually a little bit easier because with 4 terms, we are going to use factor by grouping, which is part of the steps that you do when you factor a quadratic using the ACB method, right? When we take that middle term and we break it up into 2, we're left with 4 terms, and then we just group them together. So when there is a polynomial with 4 terms, you just group the first two together and group the second two together. There's no guess and check for this type of problems. You do have to factor by grouping. So when there's 4 terms, you know you have to group them together. And then, so the first thing we're going to do is group them together, group the first two and the last two together, and then you're going to factor out the GCF from each group. So from my first group, it looks like I can divide out an x squared from both the x cubed and the 7x squared. And then I'll be left with x plus 7. And then from the second group, it looks like I can divide out a negative 9 from both groups. And again, I'll be left with x plus 7. 63, negative 63 divided by negative 9 is positive 7. And then from both of these groups, they have an x plus 7 in common, so I can factor that out. I'm just going to cross them out because I'm going to take them out. And I'm left with x squared minus 9. Okay, and then from there, once I factored, if you have a quadratic as one of your factors, see if you can factor it further. Like in this case, we have x minus 9, which is a difference of 2 squares. This is a quadratic that can be factored further into x plus 3 and x minus 3. That was one of our special cases. X squared minus 9 can be factored into x plus 3, x minus 3. And if you're not sure how that turns into x plus 3, x minus 3, just do your ACB method, right? Or guess and check. 2 numbers that multiply to give you negative 9 and add to give you 0. Factors that multiplies to give you a times c, which is negative 9, and add to give you b, which we don't have a b term, so it's 0. And my numbers are 3 and negative 3. So again, I want you guys to try one on your own. You can pause and try it and then see if you get the same answer as me. And if you don't, then you can come back and rewatch it. So GCF is going to be x squared. If I divide out an x squared, I'm left with x plus 3. From the second group, GCF is 10. Divide out the 10, I'm left with x plus 3 again. Okay, and then from both of these groups, I see that they have a common factor of x plus 3, so I'm going to take that out. And I'm left with x squared plus 10. Okay, now I see that, all right, this is a quadratic, so I'm going to see if I can factor it. Let's see if I can find factors that multiply to give me 10 and add to give me, I don't have a b term again, so 0. Do I have any factors that can multiply to give me 10 and add to give me 0? And you can try, but we're not going to be able to find one, so it doesn't exist, right? That means I can't factor this quadratic any further, and this is my answer. That's it. If I can't go any further, then that's it. Thanks, guys.